So today, let us try to understand the concept as well as the method of performing the experiment for getting the coefficient of viscosity of water with the help of Poiseuille's method. Viscosity coefficient of water with Poiseuille's method. So let us see the instrument first. The total base of this instrument is this. For leveling this base, two screws are there. This is one of the screw and this is the second screw. These two screw, with the help of these two screw, we can make it horizontal. Next in the instrument is the manometer tube. Can you see this is first arm of the manometer tube, the second arm of the manometer tube. Then there is a constant level tank. This is known as the constant level tank. I will explain you how it is constant level tank. This constant level tank, it is attached to a screw. This is the screw, with the help of which we can lower this tank or raise the level of the tank. To lower or increase, this is the head which is rotated. You can see when I am rotating it, the container is coming down. So in this way we can lower or raise the level of the tank. Next is the outlet point from where the water comes out, and that water is collected with the help of a beaker or a measuring flask. So before going further, let us see what is constant level tank. In this tank you can see three inlets: first inlet, second inlet, and this is the third inlet. So these three inlets are there. The first inlet, the lowermost inlet, is the input, the middle inlet is the output, and the last this is overflow. So when we keep the tap on, even if the water comes regularly, the height of the water cannot rise above this. So this is constant level tank. Now the most important thing in this is the capillary tube. So this is the capillary tube. Through this the water is flowing and this tube is horizontal. So obviously the Poiseuille's formula is applied, which is the formula to show the amount of water flowing per second through a horizontal pipe. So that is the principle. Now you can see here the outlet of this is connected to this point. From this point the water can go this side as well as this side. So this side is connected to a manometer tube, one arm of the manometer tube, and second part is connected to the one end of the capillary tube. Similarly, when you go to the second end, again here this point is connected to manometer tube also, and it is connected to the output. This is the output from which the water comes out, and we take the water from this outlet terminal, from this terminal which is the outlet terminal. Okay, so now the pressure applied at this point is distributed to the capillary tube as well as the first manometer. The pressure at this point is distributed to the output as well as the manometer. So the pressure difference applied across these two terminals, it is basically applied between the two ends of this capillary tube. Now the next instrument is this measuring cylinder, and because we are going to use it, we must know how to get the least count of it. So you can see this is the mark of 40 ml, this is 40 ml, and this one is the 50 ml mark. So between 40 ml and 50 ml, it is divided into 10 equal parts. So each one will be belonging 10 divided by 10, that is equal to 1 ml. So it can at least measure 1 ml. At the same time, if you see the bottom of this flask, the bottom of the flask, you can see here, there is no graduation between 0 to 5. So you cannot measure less than 5 ml with the help of this. You cannot measure less than 5. You can see it is now visible. There is no mark from 0 to 5. So you cannot measure 0 to 5 ml. So whenever you have to take the reading, please take the volume of the water greater than 5 ml. So that's all about the instrument. Now we will learn how to do the experiment. First we open this bib cock to allow the water to come inside the tube, and we allow the water to be up to the level of overflow tube. This is the overflow tube, as I told you. So the whatever excess water is there, it is going to come out of the overflow, and the level of the tank, level of the water in the tank is going to remain the same. As we do this, the level in the manometer in both tubes, the level of the water becomes constant, and you can see here now the level of the water in both the arm is approximately equal to 27 centimeter. So this situation is achieved by opening the tab, waiting for some time so that the level becomes equal in both of the arms. Now we bring down the second arm, right side arm, level of the right side, that is the output tube, a little below. We fix it a little below. Now we start rotating this screw to increase the level of water in the left hand side manometer arm. We want to raise its level a little bit, so we are rotating it to increase the level of water in the left side arm. And you can see here, by rotating the screw, we have raised the level of the left side's arm to 27.5 centimeter, and the right side arm is at say 27 centimeter. So there is a difference of 0.5 centimeter created. Now when this difference is created, now we have to measure the amount of water flowing per second. And for measuring the water, we insert the measuring flask just below the water which is coming out of the output. See, we have kept it just below it, and as we have kept this, we are going to, at the same time, same instant as we have inserted it, at the same time we have to start the stopwatch. To measure the amount of water, which is collected in the measuring flask. Yes, now you can see the water collected in 1 minute, that is 60 seconds. It is 5 ml, 6 ml and 7 ml. 8 ml, approximately 8 ml, but at 8 ml mark has not been crossed. So we are going to take the lower meniscus, and obviously we are going to take the reading, which is the 7 ml. 7 ml water has been collected. So that is value of V, volume collected 7 ml, time is equal to T is equal to 60 seconds. So we have taken 4 readings. We have taken 4 readings, the reading of left arm, which is 27.5, the right arm, that is equal to 27.0. So the difference, that is height difference, pressure difference, is of 0.5 centimeter, Now we have collected the volume of water in 60 seconds. So value of T becomes equal to 60. And the volume collected is equal to 7 millimeter of water or 7 cc of water, cubic centimeter of water. So this is the first reading. Now to take the second reading, what we have to do, that I am going to explain you. Again we are going to rotate this screw in such a way that the level of the water in the left arm is going to increase. You can see slowly the level is increasing, and we are going to make this level equal to 28 centimeter. Slowly, see, we have crossed 27.5, and this is 28 centimeter. Now the lower meniscus is at 28 centimeter, and the right side meniscus is still at 27. We have to keep it 27. So in this way we have to create a difference of say 1 centimeter. What I see, the left level has also increased, so we are going to increase continuously the left level, so that the difference of 1 centimeter is created. The left side is reaching approximately 27.5 centimeter mark, and that's why we have to keep the right side at 28.5 mm. We have to keep it at 28.5 mm, so that the difference of 1 centimeter is created. Okay, so it is now 27.5 and 28.5. You can see the readings 27.5 and 28.5. 1 centimeters difference is created. You can see it. I am going to rotate it for you. This is the level difference between the two arms. So this difference is created, and with the help of this difference we are again going to collect the water. For the same time interval of 60 seconds. You can see 1 centimeter difference has been created. It is more than 1 just now, because the lower arm has come down a bit. You can see it. The reading of the right arm is around 29 and the left arm is around 27.5. So I am going to reduce it, and I am going to reduce it to 28.5. Not 29, I have going to keep it 28.5, because the lower arm is at 27.5. I am going to reduce it to 28.5, so that the difference of 1 centimeter is created. Now you can see it is 28.5 and the lower arm is 27. Still I am reducing to make 1 centimeter difference. Now it is 28 and 27. See, it is 28 and 27. 28 centimeter and 27 centimeter. It is 28 and 27 centimeter. 1 centimeter's difference is there between these two. Now again we start repeating the experiment. For this, what we do, we are going to, so let us see, we are just going to insert it below and start the stopwatch. Both things are simultaneous. The process will continue for 1 minute. The water is getting collected inside the beaker, and ultimately after 60 seconds we are going to pull out the beaker and switch off the stopwatch. So in 1 minute the water collected will be obtained inside the jar measuring cylinder. You are looking both the process simultaneously. The time is increasing, the water is getting collected in the beaker. Yes, it is 42 seconds. (52, 53, 54, 55, 56, 57, 58, 59 and 60). Okay, so we are having the time interval now. it is 68 seconds, 60 seconds and 60 seconds, 60.84 second, 60.84 seconds. And in this, the water collected, I have collected it, and let me see how much is collected there. Now see the reading of the measuring cylinder. It is 10 ml. So when the pressure difference is kept 1, the water collected is around 10 ml. So this is the second set of reading I have obtained. I am going to do the same for different pressure differences created across the two arms of the manometer. The same can be continued till the flow of the water remains steady flow. That is, the water coming out of the outlet is in the form of trickles. When it becomes continued, the pressure difference for which it becomes continued, we are not going to take the readings, because the formula is valid only for steady flow. It is not valid for turbulent flow. So till the pressure difference till which the flow of the water remains in trickles, we are going to take the reading. So approximately 8 to 10 readings you are going to get in this experiment, and that 8 to 10 reading now is going to be tabulated, and the tabulated readings are then calculated, and we are going to show the viscosity of the water by calculation. So now let us see the readings taken in the experiment. Initially, the left arm was kept at 27, right arm at 26.5. So the pressure difference was of 0.5 centimeter. Volume collected in the measuring cylinder was 7 mm. Time taken was 90 seconds. So when 7 divided by 90 gives us the volume per second, that is 0.078 cc per second, cubic centimeter per second. Now if I divide this h, that is 0.5, by 0.078, what I get is h by q. Similarly, in the second reading, we raised it to 27.5. It was still 26.5, so the difference between these two is equal to 1 centimeter. Volume collected was equal to 14 ml or 14 cc in 90 seconds. So 14 divided by 90 gives us 0.156 cubic centimeter per second is the volume collected per unit time. Now dividing 1 by 0.156, we get it 6.43 again, h by q. So in this way, by raising the left arm with respect to the right arm, we go on making different distances, and you can see here, because this is in my hand to adjust the pressure difference, so the adjustment is gradually increasing. That is, first time it was 0.5 centimeter, for the second reading 1 centimeter, for third it was equal to 1.5 centimeter, fourth it was 2 centimeter, for fifth reading it is 2.5 centimeter, and so on. So by all these reading we get different values of h by q, and ultimately we add all these 5 h by q's, 1, 2, 3, 4, 5, and divide it by 5 to get the mean h by q, which is equal to 6.22. Now the length of the capillary which is given, it is 32.5 centimeter. Diameter of the capillary tube is 0.159 centimeter. Density of water is 1 gram per cc. Acceleration due to gravity is standard, that is 980 centimeter per second. Temperature of water was 30 degrees centigrade. If the radius is 0.159 centimeter, so obviously radius will be 0.159 divided by 2, that is equal to 0.0795 centimeter. So this is all about the readings which we have taken. Now we are going to have the graph and the calculation. Now this is the calculation. Formula is eta, that is viscosity, is equal to pi r to the power 4 rho gh divided by 8 LQ. R is the radius of the capillary tube. This is the density of the water. G is the acceleration due to gravity. L is the length of the capillary tube, and H by Q is our observation. We have already calculated the value of H by Q. So putting the value, eta is equal to 3.14 multiplied by the radius to the power 4, that is 0.0795 whole to the power 4, multiplied by 1 gram per cc density, 980, that is acceleration due to gravity. H by Q is 6.22 divided by 8 into length of the tube is 32.5. On calculation we get 2.94 into 10 raised to 3. That is the value of the viscosity of the water, which is very near to the standard value, that is 3 into 10 raised to minus 3. If we take the value of H by Q by graph, then only difference will be, it is same 3.14 multiplied by 0.075 whole to the power 4 multiplied by 1 gram per cc multiplied by 980 centimeter per second square multiplied by, instead of 6.22 we are keeping 5.71 divided by 8 into 32.5, which is equal to 0.072 divided by 260, which comes to be equal to 2.7 into 10 raised to 3 poise, which is again very near to the actual value of the viscosity of water. So that's all in this video. I think you have understood the process very well, and I also expect from you that you are going to perform also with the same accuracy with which the experiment has been performed.